All right. So welcome to 8.1. So we're not going to hit 7.4. We're just going to dive into chapter 8. So in chapter 8, we are going to take and somewhat consolidate. We're going to somewhat consolidate all of the topics that we would have covered in chapter 3, in chapter 7, and we're going to apply them per scenario. So you're going to see a lot of carryover from chapter 7, in fact, chapter 6, 7, and 8. So these chapters are going to begin to blend in together. In 7, okay, we talked about estimations for a population proportion, for a population mean, or for a population standard deviation or variance. Those are the three things that we hit in chapter 7. In chapter 8, what we're gonna dive into is what's called hypothesis testing. And so essentially we're gonna have some claim. We're gonna have some claim about a population mean, or some claim about a population standard deviation, or about a population proportion, mean, or standard deviation. Yeah, so I'm gonna have what's called a claim about those. In this section, or in this chapter, we're going to make some. So let's see. We're gonna answer the question of significance. So I think it's in chapter 3, we would have talked about significance as the mean plus 2 standard deviations, or the mean minus 2 standard deviations. And that's kind of where we stuck with significance. But we're going to hit significance a little bit more in this chapter, and we're going to get a little bit more precise. Chapter 8 is kind of like really digging into, or I should say starting into, where a lot of statistics lives. So all the chapters up to this point, you can think of them kind of like as learning how to use a fork and a knife and a spoon, right? You familiarize yourself with the utensils or with the tools. In chapter 8, you really begin to start applying those tools. This is where most, like most statistical stuff is going to live. You're going to have a thing that we think is true, and then we're going to have something that we're trying to prove or disprove, okay? And so you'll go back and forth. So before I just keep rambling on, let's actually dive into this, okay? So 8.1 is hypothesis testing, okay? Within this section, what we want to cover is we want to identify what's called the null and alternate hypothesis. I will probably abbreviate hypothesis as HPY a lot. We want to learn how to calculate the test statistic, and then we want to calculate the p-value, which you've already been doing that, we just haven't actually named it. And then we're going to talk about this thing called reject or fail to reject. Okay, so I'm going to do one of the two things. I'm either going to reject it or I'm going to fail to reject it. Okay, so these are the things that we're going to hit in 8.1. So within this section, okay, you're going to hear a lot about what is the null hypothesis and then what is the alternate hypothesis. Okay, a hypothesis in itself is a claim about, can you read that? Is that too small? That's getting pretty small. hypothesis is a claim about a property of a population, okay? A property of a population. And when we say the word property, what that's implying is the mean, the variance, the standard deviation, or the population proportion, okay? So this is a fancy way of saying there is a claim, okay, a statement, a original claim about one of these properties, okay? And we've gone through and we found that if I'm talking about a mean, then I'm either going to use my z or t table, depending on if my delta is known. For a variance or for a standard deviation, we're going to use our chi distribution, and then for a population proportion, we're going to use our z table. So within chapter 8, we have the opportunity to use one of 3 charts. Okay, so a hypothesis is essentially a claim. Okay, now when we perform a test, okay, a hypothesis test is just that. It's going to be a procedure for testing a claim, okay? And it's going to have some value. It's going to have some value associated with it. Now, within a hypothesis test, we're going to have one of 2 things. We're going to have, well, not one of 2 things, but we have 2 things that we're going to be examining, okay? You're going to have what's called a null hypothesis or the alternate hypothesis. So the null hypothesis and it's generally denoted as H sub 0. You will hear me talk about it. You'll hear me say H naught a lot, N-O-T, whenever you have something sub 0, then it's going to be subscript 0. It's going to be like initial, not, original. There's a lot of different ways that we can refer to it depending upon the context of the problem. You'll hear me say H naught a lot. Doesn't mean that H initial is wrong. It's just that's the terminology that I like to use. So the null hypothesis is the original claim. The null hypothesis is the original claim. Sorry about that, my phone was going off. So the original claim, think of this as kind of like our legal system in the United States. So you are innocent until proven guilty unless there is probable cause. So we are going to assume that the original claim is always true until we have proven it false, okay? So that's why we use the terminology reject or fail to reject, okay? So when we're saying reject and fail to reject, what we're talking about is our null, okay? Our null hypothesis, or H naught. I am either going to reject it or I'm going to fail to reject it, which means I'm going to keep it, okay? The test failed, so I'm going to fail to reject it, or I'm going to keep it. So null hypothesis is going to be our original claim, and sorry, my notes got backwards here. So null hypothesis is going to be original claim, and then we are going to form it, or we're going to shape it into a mathematical statement that contains equals, okay? That contains equals. If you're looking for the null hypothesis or the alternate hypothesis, the null hypothesis will not always have equals in the original problem. We're gonna shape it to where it will, okay? As we go through, you're gonna kind of see it take shape. But the null hypothesis is always going to be connected to the equal sign. The alternate hypothesis okay, and that's usually denoted, that's denoted a few ways. So you've got h sub 1, you've got h sub lowercase a, or you have h sub capital A. Any one of them will do. I don't care which one you use. I usually use h sub lowercase a, and I will oftentimes refer to it as h sub a, or the alternative. So the alternative hypothesis is a statement that the parameter, okay, parameter being mean, standard deviation, proportion, a statement that the parameter differs from my null hypothesis, okay? So the alternate is always going to have either a less than, a greater than, or a not equal to. Less than, greater than, or a not equal to. The null hypothesis will never have any of these symbols within them. This will only be connected to the alternate hypothesis. Now, when we're conducting a test, it's convenient for us to have kind of like a roadmap in order for us to, guide us kind of through the process, because these get a little bit cumbersome. There are several things to it. So your book goes through this checklist, roadmap, however you want to call it. I would recommend that you look at it, understand each step, maybe add some steps in there if you wish. Okay, this is just a general rule. This is not the end-all be-all. But so let's say that we're going to conduct a hypothesis test. We're going to go down through our checklist of operations. As you go through this, I think you're going to find that some of these are intuitive or natural feeling, especially if you have a decent understanding of chapters 6 and 7. You're going to say, oh, well, yeah, I need this, and oh, yeah, well, that makes sense, I need that. So hopefully some of these steps will feel somewhat intuitive to you. So before we can do any kind of math, I have to identify the claim. That claim could be, so let's take the scenario that you work in a factory that produces pencils. The pencils on average are supposed to be 6 inches. And someone says, hey, these pencils are not 6 inches long, they're actually 7 inches. So within that, your original claim is that you have 6-inch pencils. The alternate claim, or the alternative hypothesis, is that your factory is producing 7-inch pencils, okay? So when we look at the problem, we say, okay, what is it saying? What am I examining? We're going to identify the claim, okay? Essentially, I'm gonna really read the problem. Step 2, I want to incorporate symbolic form, meaning I'm going to throw in my equals, I'm going to throw in my less than, greater than, I'm going to throw in my not equal to, I'm going to throw those pieces in so that I can track which one is my alternate, which one is my null, okay? Which one is which. Step 3, I am going to once I put the symbols in, I'm going to identify which one specifically is the null and which one is the alternate. That's going to be given by the symbology. So h sub naught is going to have equals. H sub a is going to have less than, greater than, or non-equal to. It will not have all three. It's going to have one of the three. You either will have something less than, something greater than, or something that is not equal to, okay? But you will not have all three. Step 4, you are going to identify or select, maybe let's say identify, because they should tell you. So select significance level, okay? Selecting significance level, that should be something that you can pull out pretty quickly. So chapter 7, chapter 6, that's going to be our alpha, right? So we're either going to have, so the common ones are like 5%, 2%, 1%, or 0.05, 0.025, or a 0.001. So, I'm sorry, 0.01. So, no, that's right, 0.05, 0.025, or 0.01. So you're going to want to just go through the problem and read it and identify what is your significance level. Make a note of it, because then we're going to, apply that to our critical values and the charts, and all of that stuff is going to compound on itself. This this section is so 6 and 7 were what we could say to be compounding, but this one is even more so. So like we've got this, we're creating this list, so to speak, of things that we need to do in order to conduct a test. If I miss something here, it's going to trail all the way down. So getting each one of these steps is very important, because this one is going to bleed into this one, which is going to bleed into step 5 and step 6 and step 7 and all that kind of business. So we really want to make sure that we're dialed in on these steps. So step 5 is going to be to ID the test statistic. So now I want you to think of test statistic. It is very much so. It's very much so a critical value. So in your in chapter 7, okay, you would have found your critical values from a confidence level. So whether it was chi, whether it was chi, t, or z, you would find a critical value, and that was kind of it. In this case, my test statistic is going to be a critical value. I'm going to crunch it, I'm going to find it, but that critical value is then going to bleed into either an area under the curve, or I'm going to do a straight comparison with critical values. So this critical value that I'm going to find is then going to be compared to some levels of significance, or potential area under my curve, but this is very much so a critical value, and we're gonna write down in fact, let's go ahead and do that. So for our criticals, for our test statistic, So I'm going to have one of 4 conditions that I'm going to have to investigate. I am either going to have to investigate whenever I have a population mean, whenever I have a population mean Yeah, so a population mean with delta known, or I'm going to have a population mean with delta unknown. Let's say not known. And this should carry over. This is carrying over from 7.2. So in 7.2, we talked about how that if my delta is not known, then I'm going to use a t distribution. If it's known, I'm going to use a z distribution. Very much so the same flavor. Okay. So in order for me to do a hypothesis test on a population mean, okay, if my delta is known, then my formula that I'm going to use is z is equal to my sample proportion minus my population proportion. Sample proportion minus population proportion divided by the square root of my population times q, my population proportion times q divided by n. Can we see that? Barely. I'll write a little bit bigger, sorry. Remember that anytime that you see q, q is 1 minus p. Okay, so whatever my whatever my population proportion is, minus 1, and I get my p-value. If my delta is not known, okay, delta is not known, that's going to push me to my t-value, my t distribution. That's going to be my sample mean minus my population mean divided by the standard deviation divided by the square root of n. I shouldn't have wrote those boxes, we don't actually need them. Now, if I'm doing a population proportion is going to be a man, I'm so sorry, I wrote down the wrong equation here. This one's wrong. That should have been x minus my population mean divided by my delta divided by the square root of n. So these two are very similar. The only thing that is different is delta and s. Okay, so known, not known. Now, population proportion, okay, that's going to push me to a z value or a z critical value, and now the equation that we wrote there, p hat minus p divided by the square root of p q over n. And then last but not least, if we are looking at a delta or a delta squared, which would be our population standard deviation or our population variance, that's going to be a chi distribution. So a chi squared, which is going to be equal to n minus 1 times s squared divided by delta squared. Now, within your problems, there should be information that is going to indicate to you whether it's a chi zt or t, or in other words, if I'm dealing with my mean, if I'm dealing with my population proportion, or if I'm dealing with a variance or standard deviation. That should be terminology within the problem that stands out very prominently to you. In other words, you'll be able to read it, and they will ask you specifically, and they will use the words mean, variance, standard deviation, or proportion. Okay, so we identified the test statistic. We have identified which one that we're going to use. Step 6 is we are going to actually calculate that test statistic. So find it. and we're going to find the p-value. Now that's a little bit new. We haven't talked about the p-value, we haven't talked about p-values yet, but you have actually been finding them this entire time. So in chapter, chapter 6, okay, you would have dove into a normal distribution, right? And so we would have said, hey, calculate, find the probability associated with the z-value of 1.25. Okay, and 1.25 would have been that direction, right? Because z-values measure from left to right. I don't have my chart with me. I don't know what that is off the top of my head, but so this measures from left to right, right? So we would have gotten this area over here. The p-value is its complement. So this area right here is considered to be my p-value. So nothing extremely new. We've been doing this for a while. We just haven't articulated it. Now it's not restricted to a normal distribution. We can have that for a chi distribution. We can also have that for a t distribution. So p-value, think of p-value as kind of a complement thing. All right, we're almost done. Now, for step 7, we are going to I'm gonna need more room. For step 7, I've got one of two things that is going to happen. So again, within your problem, it should tell you what it wants you to measure, and so you will either measure measure things in terms of a p-value, or you will measure things in terms of a critical value. We're going to do an example here in a few minutes of both, and so you'll kind of get to see the crossover. They're going to give you the same answer. It's just that one problem is going to want you to look at it in terms of a probability, and then one is wanting you to look at it in terms of a critical value. So let's say, okay, for step 7, let's look at the p-value. What we'll say is the method, the p-value method. Okay, if the value, so if p-value associated with h naught is less than or equal to alpha, okay? If it is less than or equal to alpha. So in other words, so let's do this. So if it's less than, okay, we are going to reject the null hypothesis. Okay, we're going to reject the null hypothesis. Let's talk about this for just a second. So the p-value, okay, remember the p-value is the area underneath the curve. My alpha is also an area, okay? An alpha is going to be a level of significance. So we're going to have, a level of significance of like 0.05. So let's say that my alpha was equal to 0.05, and I found a p-value of 0.005. Okay, a p-value of 0.005. This p-value was found whenever I took my test statistic. I would have gotten some sort of, let's say, a z-value. Okay, it could have been a z, t, or chi, but we're going to say that it was a z value. So let's say that we got a z value of 2.00, and that gave us some p value. So we would have looked this up on the curve. We would have looked this up on our chart, excuse me. We would have subtracted it away from 1, and then we would have gotten some p-value. Let's say that that p-value is 0.005. If you were to look this up and this up, these will not match. I am making junk up, okay? So if you look this up, you're actually going to get the accurate p-value, but we're going to think and assume that it is 0.005, okay? That's the area in the right tail of my normal distribution. That's that area right there, okay? I take this number and I compare it to this number. If my p-value is less than or equal to alpha, I reject it, okay? My p-value, 0.005, is indeed less than 0.05, okay? 0.005 is less than 0.05. So if my p-value is less than alpha, in this case, hopefully you're saying that you would reject it, okay? So that's what we're saying when we're talking a p-value. Now there's two sides to this coin. I have to reject and I fail to reject. So I also have the condition of if my p-value associated with my null hypothesis is greater than or equal to alpha, okay? Hopefully you're screaming at me that I'm going to fail to reject it, okay? Fail to reject it. This is our p-value method. This is how we are going to say we're going to reject the null hypothesis or we're going to keep the null hypothesis, okay? Now, let's say that we're going to use the critical, okay? So all of this is the p-value method. Now, let's talk about the critical method, okay? Critical method is going to be very similar, but instead of comparing a area, okay, instead of comparing two areas, now what I'm going to compare is I'm going to compare that critical value that I found from my z statistic, and I'm going to compare it to the critical value associated with my confidence, okay? If you have, right, so if you have a 95% confidence, I believe it's 1.96 is your critical value. So I'm going to take that critical from my confidence and I'm going to compare it to my critical that I found for my test statistic, okay? Now, if critical value associated with H naught, or the null hypothesis, is in the critical region, if it's in the critical region, then I am going to reject it, okay? If it's in the critical region. Now, what does critical region mean? Critical region, again, we're gonna have a, let's say that we're doing a normal distribution, okay? And let's say that we have a z-value of 1.96, okay? We're going to get into a few more details here about which side is going to be considered critical, but let's assume that our left side is critical, okay? So we're going to say that this side is critical, and we'll get into how we decide that here in a minute. If this side is critical, this is my critical value associated with my null hypothesis, or the initial confidence level. Wait a minute, take that back. Okay. I take my critical value associated with my confidence. Then I take my critical value associated with my null. That is going to be found from my test statistic. Okay. So then let's say that our test statistic is 2.0. 2.0 would be right there-ish. Okay, 2.00 is right there-ish. Because this value is within this region, that's going to tell me to reject the null hypothesis. Reject it. Okay? And then the converse is true. If not in critical region, we are going to fail to reject. Okay? What that means is that Z might be something like 1.50. Okay? Maybe Z is 1.50 and it's on the other side of my critical region, then I fail to reject it. Okay? These are going to be the two methods that I'm going to use. I'm either going to use a critical method or I'm going to use the p-value method. And I'm going to use the critical value and p-value method with either a z-table, a t-table, or a chi. So I have got a lot of options that I can go with, okay, depending upon what my problem states. So it's very, very important. It's very important that we read through the problem very carefully. And that we understand what it is exactly asking us, because I could wind up on the wrong chart, right? I don't want to do that. I want to make sure that I'm on the right chart. So once we get through step 7, okay, we're pretty much done with all of the mathy kind of stuff. But in step 8, what we're then going to do is we're just going to restate the problem. You see up here? Yeah. So for step 8, we are going to restate. We're going to restate the problem. And what that means, essentially you're going to have, you're going to use terminology of, we do not have sufficient evidence to, accept the alternate hypothesis, thus we fail to reject the null hypothesis. Okay, so there's going to be 2 parts to this section. This is a little bit of a loaded section, so we're going to get through what we can get through today, and then we're going to dive into some problems and some phrasing type of stuff on step 8 in the second part of the video. So for part 1, we're just going to kind of hammer out these details. Okay, so now what I wanted to do is, in your book, there is an example of what there's an example of people that are comfortable and uncomfortable with drone delivery. And so what we're going to do is we're going to get through it a little bit. We're not going to get through all of it today, but we're going to conduct a hypothesis test. So take a screenshot of this, write this down. Hopefully you've written this down, because we're going to get rid of it. So in your book, they say that roughly that of 1,009 customers, roughly 50% of them are uncomfortable with drone deliveries. And what they want us to do is to say, well, what's a significant threshold? So among the 1,009 is, I think it's like 545 or something like that, is 554 people considered to be significant. So our original claim our original claim about drone deliveries is that the proportion of individuals that are uncomfortable with drone delivery is 50%. Okay. Our original claim, our null hypothesis, is that individuals, there are 50% of individuals are uncomfortable with it. Okay, that's our original claim. So, like, if we're going down through our steps, okay, our step one is that we would identify. Okay, so step one, identify the claim. The claim is that 50% of people are uncomfortable with drone deliveries. That's our claim. Okay. Step two is that we're going to throw in some symbology. Okay. My null hypothesis, my original claim, is that 50% of people are uncomfortable. That's my original piece. So within just this little bit of writing up here, I've kind of covered a few steps. I've covered step number one. So you could choose to write down the claim, or you could choose to not write down the claim. I'm okay with either. But you definitely do want to write this down. What is my null hypothesis statement in mathematical notation? So my null hypothesis is going to be 0.5. Now, what we want to figure out is that are there more than 50% of people that are uncomfortable with it? So our alternate hypothesis is that more than 50% of people are uncomfortable with it. Okay? So these are going to be the two things that we're going to be bouncing around back and forth on. Okay? So within this problem, so within just these two pieces of writing, we've covered step number one, we've covered step number two, we've covered step number three. Whoa, focus. There you go. Step number four is going to be to select the significance level. So the significance level in this problem, their alpha is 0.05, and so that would translate over into a 95% confidence interval. So we now know our claims and we know our significance level. Okay. We need now to determine what test statistic am I going to use. So within this problem, we're saying that 50% of the population is uncomfortable, or we're saying that a percentage of the population is uncomfortable with something. Whenever you see percentage of a population, that's a proportion, right? That's a proportion of the population, or the proportion of a sample. Proportion for a sample, proportion for a population, those are going to be percentages, okay? So in this one, we've got a population proportion. So for a population proportion, our our test statistic that we're going to use is p hat minus p over the square root of p times q over n. Okay, this is the critical. This is the test statistic that we're going to use in order to find it. Now, for us, where did I find it? It's right here. Okay. So the amount of people that they sampled is 1,009, and the amount of individuals that said that they were uncomfortable, or we're assuming the amount of people that they said are uncomfortable, are 545. We're going to take and divide this. This is going to get me our p hat. So x over n is equal to p hat, which is equal to 0.540. So p hat is equal to 540. We already know what p is. We have identified that p is equal to 0.5. Q is 1 minus 0.5, so 0.5. So we can go and crunch all of this. So we've got 0.540 minus 0.5 divided by the square root of 0.5 times 0.5 divided by n, which is 1,009. That's going to get us a grand total of 2.54. Remember, that's a critical value. that right there, that's a critical value. We can use that as a standalone, or we can associate an area with it. That's my test statistic that I want to compare to my level of significance. Now, once I have found my test statistic, okay, I need to identify the critical region. Where am I going to put it? Okay, and this is what I said. This is what I said we're going to get back to. So we've got 3 conditions. Okay, we're going to cover one of them today, but we're going to have 3 conditions as far as a critical region goes. I am either going to have a left tail, I'm going to have a right tail, or I'm going to have a two-tail test. And this is why on your charts that there are, on your ZT and Chi, whenever you have at the very top it says one tail or two tail, this is one. You're going to have tests that are going to be one tail, two tail, or one tail, two tail, or right, left, or two tail. So if my alternate hypothesis is less than some value, okay? If my alternate hypothesis is less than some value, then I'm going to have what's called a left tail test. Can you still read that? Not really. So, left tail. Okay, if my hypothesis, my alternate hypothesis, is greater than, I'm going to have a right tail. That's referring to this piece over here. That's my critical region. Okay, that's my critical region. And then if my alternate hypothesis is not equal to some value, that's going to be a two-tail test, which means I'm going to have critical regions on both sides. Okay. Now for ours, what we can look at is we can look at this phrase right here. Okay. I got P is greater than 0.5. That is going to fall into a right tail test. Okay, a right tail test for us, which should kind of make sense. Z to be 2.54. That's on the right side of my distribution table. Okay, but we want to be able to double check that because sometimes there may be cases where they're really close, and like if they're really close and it's on the wrong side, then it's going to push me to reject it, and I don't want to reject it. Okay, so get back over here where I'm at. Okay, so let's go with the p-value method first. So we're gonna do both. We're gonna do the p-value method, and then we're gonna do the critical value method. So let's go p-value method. Regardless of which one I'm going to use, I still have to use my criticals. Okay, whether it's a p-value or not, I still have to use them. So we've got our critical value associated with 0.5. So z of 0.05 is equal to 1.96. So let's say that 1.96 is right here. Okay, that would imply that my alpha is 0.05. Okay, 0.05. Then I've got a critical value over here of 2.54. And let's say that 2.54 is right here. Remember, this is a right tail test. This area over here is considered to be my critical region. Critical region, okay? Right tail test, this is my critical region. Now, what we want to do is we want to compare the area associated with this critical value and the area associated with this critical value. The area associated with this critical value, you're going to take this value, now okay, so bear with me for a second, 2.54, okay? If you were to go and look that up on your chart right now, you're going to say, well, dude, that's like 0.9 something. And I would say, yeah, that's absolutely right, because a z-value measures from right to left. I don't want to know what's right from left. I want to know what's over here. In order for me to get this, I got to subtract the area over here from 1. Okay? I got to subtract the area over here from 1. I wish I had my chart on me, but I don't have my chart on me right now. If I take the area from the, if I take it from 2.54 on the right, it's going to get me like 0.9 something. On the left over here, this p-value, remember this is my p-value, that's going to be equal to 0.005. That's where I got that number from at the beginning of the class. So at a z-value of 0.54, okay, my p-value associated with that is 0.005. Now, I want to compare 0.005 with 0.05. So my p-value is, in this case, less than or equal to my alpha, because 0.005 is less than 0.05. Hopefully you agree with that statement. Be very careful with your zeros and make sure that you're squared away on what is what's a bigger value, 0.005, 0.05, 0.0025, 0.025, all that kind of jazz will get you in trouble. So we said, okay, that if my p-value is less than or equal to my alpha, I am going to reject it. So within this statement right here, this tells me I am going to reject my null hypothesis. It's gone, okay? So this would be the end of step 7, okay? Now, we already got our criticals up here, so we can go ahead and hit the critical method as well. Once we put our criticals up there, all I have to do is identify what is my where is my test statistic in relation to my confidence, the critical value associated with my confidence. My test statistic is in the critical region. So because it's in the critical region, it's a no-go. So that would be a confirmation that I'm going to fail to reject it. The critical method, I think, arguably is going to be the simpler method for sure. Where you got to be careful is your original statements. If your original statements are off, that means that your left and right tail tests that we wrote over here are going to be backwards, which means that if this is backwards, I would say, oh, well then this over here is my critical region. My critical value is not in my critical region, then okay, I'm going to fail to reject it. Not so. So I have to get my original statements correct. Once I get my original statements correct, everything else is going to be able to fall in place. This right here, this is going to be a pretty straightforward formula. There's not a whole lot of guessing and checking there. Here, all I got to do is put the numbers where they fall in order, right? Like I got to make sure that I have the smaller one first and the bigger one second. I just got to throw them up there. For my p-values, I do have to think about what side my distributions measure. Chi measures from left to right, so that's going to be a bear whenever we calculate that. You want to keep that one straight. Z measures from right to left. I got to keep that one. I got to keep that one straight. Okay. So this is as far as we're going to get for today. So this is going to be like our part 1. We'll get into part 2. But this is going to be hypothesis testing. We're going to spend the rest of the semester on chapter 8. We're not even going to get into chapter 9. So crunch this, think about it, digest it, okay? We've still got a lot of pieces that we haven't covered yet. We haven't covered the two-tail test. We haven't covered anything about mean or standard deviation. And we also haven't hit the interpretation piece. So even just within this problem, I'm still not quite done because I haven't restated the problem. But at any rate, okay, this is it for the day. We will see you in the next video.